Good day, everyone. This is the house of Gamaliel. I am Princess Laika Topasio, the house leader of this group. For today's video, we're going to discuss about the confidence interval using a z-table. Are you ready? Oh, wait. I see. You didn't know what is confidence interval and z-table. Okay, so let's start. A confidence interval gives you a range of values where the true value of something is likely to be found. The confidence level tells you how sure you are that the true value falls within that range. Imagine you're trying to guess the average height of all students in a school. You measure a few students and calculate a range of heights. A confidence interval is like that range. The confidence level, for example 95%, tells you how confident you are that the actual average height of all students fall within your estimated range. A higher confidence level means a wider range. You're more certain but less precise, while a lower confidence level means a narrower range, more precise but less certain. And now, the z distribution or table is like a special ruler for measuring how likely something is happen. It's used when you have a lot of data points. Sample size is greater than or equal to 30, or when you know the average spread of your data. Imagine you're measuring the heights of all students in a school. The distribution helps you understand how many students are taller or shorter than the average height. The z critical value is a specific point on this ruler. It tells you how far away from the average you need to go to be considered unusual. We have here a table. This will be the basis to find the corresponding critical value of the confidence level. Now, let's try to solve the following problems or confidence interval using z distribution.
Good day everyone, my name is Altenebal, so let's start with our first problem. A company produces light bulbs. They want to estimate the average lifespan of their new energy-efficient bulb. A sample of 100 bulbs is tested, yielding a sample mean lifespan of 1,200 hours and a known population standard deviation of 150 hours. Find the 95% confidence interval and for the true average lifespan of all bulbs. Let's start the solving part. First, we need to identify the given. Our sample size is 100 bulbs. Sample mean is 1,200 hours. Standard deviation is 150 hours and our confidence interval is at 95%. The second thing to do is to identify the corresponding critical value. We're going to base in the C table here. We're going to find the confidence level, and if you look below it, you'll see a decimal number. And there you have it. Our critical value is 1.96.
Hi everyone, I am Crystal B. Riadique. So let's start the third and fourth steps. In the third step, we're just going to find the margin of error by multiplying our z critical value, which is 1.96, by the standard deviation of 150 over the square root of our sample size, which is 100. And the last step which is the fourth step, is we're just going to calculate the confidence interval by using this formula. So we're just going to substitute. Our sample mean is 1,200 minus the margin of error, which is 29.4, and on the other side 1,200 plus 29.4. And lastly, the confidence interval is 90% estimated average lifespan of their energy efficient bulb is 1,170.6 and 1,229.4.
Hi, I am John Joseph F. Sico. So we're going to solve this second problem. A study is conducted to estimate the average daily calorie intake of adults in a city. A random sample of 225 adults is selected and their daily calorie intake is recorded. The sample mean is 2,000 calories and the known population standard deviation is 300 calories. Calculate the 90% confidence interval for the average daily calorie intake of all adults in the city. So we're done reading the problem now. Let's start to identify the given. Our sample size in this one is 225 while our sample mean is 2,000. Standard deviation is 300 and our confidence interval is at 90%. The second step is to identify the corresponding critical value. We're going to base in the Z table here. We're going to find the confidence level and if you look below it, you'll see our critical value which is 1.645.
Everyone, today I will explain how to calculate a confidence interval using problem 2 as an example. Let's go step by step. Step 1 is understanding the problem. We are given data about the daily calorie intake of 225 adults in a city. The sample mean is 2,000 calories, with a known population standard deviation of 300 calories. Our goal is to find the 90% confidence interval for the true average calorie intake of all adults in the city. Step 2 is finding the margin of error. To find the margin of error, we multiply the critical value z sub alpha over 2 by the population standard deviation divided by the square root of the sample size. Step 3 is computing the confidence interval. The confidence interval is found using this formula. Sample mean minus margin of error less than mu less than sample mean plus margin of error, which is 2,000 minus 32.9 less than mu less than 2,000 plus 32.9. The answer is 1967.1 less than mu less than 2032.9. So we can say that we are 90% confident that the true average calorie intake of adults in the city is between 1967.1 and 2032.9 calories. This means that if we repeated this study multiple times, about 90% of the time, the true mean would fall within this range. Confidence intervals help us estimate population values more accurately. Thank you.
I am Noel Brian B. Calesa from 11 Job. Now we're going to solve for the last problem. I study on the height of sunflower yields. A sample mean of 1.8 meters from a sample of 100 sunflower. The sample standard deviation is 0.3 meters. Find a 92% confidence interval for the average height of sunflower in the population. So we're done reading the problem. Now, let's start to identify the given or your sample mean is 1.8 meters. Standard deviation is 0.3 meters and all your confidence interval is at 92%. The second step is to identify the corresponding critical value. Huwag mong galawin. Critical value, we're going to base in the Z table. Here, we're going to find confidence level, and if you look below, you'll see your critical value, which is 1.75.
So, our left and right endpoints will be 1.747 is greater than the mu and greater than 1.852. In conclusion, we are 92% confident that the true average height of sunflower on population lies between 1.747 meters and 1.852 meters. Let's continue with the third and the fourth or our last step. We need to find the margin of error by multiplying our z critical value, which is the 1.75, by the standard deviation of 0.3 over the square root of our sample size, which is the 0, and now our margin of error is 0.052 or 0.05. The last step is to calculate the confidence interval by using this formula. We're just going to substitute our sample mean is 1.8 minus the margin of error, which is the 0.052. So the answer is 1.747. Then on the other side, 1.8 plus 0.052. So the answer is 1.852.